Assalamu alaikum dear students. Today we are going to learn about liquid limit determination. It's week 9th and lecture number 17th of your Geotechnical Engineering 1 course. So let's begin. As you know, in the previous lecture we discussed the Atterberg limits. In that we learned that if we put water in a cohesive soils, in a fine-grained soil, their consistency also changes. While consistency was resistance to deformation of a soil, it means that if a particular soil has a high moisture content, its resistance to deformation or stress strain curve will be very flat, which means that there is a lot of deformation in the soil without taking any shear stress. If you reduce the moisture content in a soil, it will develop some shear strength for the given amount of deformation, and if you reduce it further, the amount of shear stress offered by the soil, the shear strength will be greater. So it means that the soil can change their behavior, especially cohesive soils can change their behavior with the amount of water. So a Swedish agriculture engineer Albert Atterberg divided those states into a different limits based on the amount of moisture present in a soil, and he called them liquid state, plastic state, semi-solid state and solid state. And in liquid state, the soil will have zero shear strength and it will just behave like liquid. In plastic state, it will have some shear strength and it will behave like a plastic substance, in which if you apply some amount of deformation, it will not be recovered. Then it will, if you reduce the moisture content further, it will turn into semi-solid state, in which it will be still saturated, but some of the deformation will be permanent, some will be non-permanent, just like we have in the solid objects or solid materials. And then if you reduce the moisture content further, the soil will turn into a solid state, in which the soil is not fully saturated and the amount of shear strength is greater in compared to the rest of the states. So then he said that when a particular soil moves from one state into another, the point at which this transition is going to happen, that is the limiting condition for that particular state. So when we mix a large amount of water with soil, it results into a soil condition, the soil being in liquid state, in which it can flow like a liquid. So in this state, the soil virtually has no shear strength. It does not have any resistance towards the shear force. So when we keep on reducing the moisture, if we start drying this soil, there will be a condition in which it will start becoming stiffer, and at a point it will start developing some resistance to shear. So the point at which it starts developing resistance to shear, this is the point where it is changing from one state to another. So it is changing from liquid state to a plastic state. So the boundary between them will be known as liquid limit. So in this lecture we will see that how we will use some standard methods over here to determine the amount of liquid limit, at which point the soil, a particular soil, will be changing its state from a liquid state to a plastic state. So for this purpose, we have two types of apparatus available in the laboratory. You will be performing these tests in the laboratory as well. Casa Grande apparatus, which you can see over here. In the laboratory you have a motorized version and manual version as well. Here you can see the hand crank with this one. In the laboratory, in some of the labs, they have the motorized or mechanized version of this as well, which are more accurate, along with the growing tool and spatula. So this is basically the apparatus used for the Casa Grande test for the liquid limit determination. And then we have a cone penetrometer test as well, in which there is a cone which is allowed to penetrate in a mixture of soil, and that can basically tells you from the gauge over here that how much is the amount of penetration. So depending on the soil being in liquid state or plastic state, the amount of penetration will be different for this standard cone. So this is just like the penetration test which you are conducting for bitumen in the laboratory. So it's just similar to that in working. So we will also discuss this cone penetrometer test as well. So first of all, Casa Grande method. In Casa Grande method, we have this standard equipment which you can see over here is ASTM standard 4318, which basically tells you the procedure, the standard procedure for conduct of this test, which includes the dimension of the standard cup as well. So in this equipment you have a brass cup, and you know, because brass does not deteriorate with the passage of time, it does not corrode like other metals, so that is why brass cup is used to prevent the soil friction along the sides of the cup. So soil pad is placed in this cup horizontally, like you can see over here, the surface is horizontal. The depth or radius of this pad cup is 54 mm, and the diameter of the rim is 46.8 millimeter. Then this is the standard grooving tool. Using this grooving tool, we will be cutting a groove in the middle over here. So the standard grooving tool has 2 mm thickness over here, and then the depth is 8 mm, and the thickness of the grooving tool at the top is 11 mm. So using this grooving tool, we will be making a groove in the middle over here, and then make sure that with the number of blows, if it is closing, it will basically indicate that the soil is in liquid state or in plastic state. So the height of the fall of this cup, because we will be rotating this crank, and this cup will be moving up and down on this platform, so striking on this bottom where there is usually a rubber pad over here, so it is usually striking against that. So it will be raised up to 10 mm and then allowed to drop freely. Okay, so this height will be 10 mm, to which it will be raised from the bottom and then allowed to fall on this base at 2 drops per second. So in 1 second, if you are doing it manually, you should make sure that you are giving it 2 drops per second as per standard. But if you are using the motorized version of this machine, this equipment, then in this case there is an electric motor which automatically applies 2 drops per second. That is why the mechanized version, or the one which does have the motor, they are more reliable, they give you more repeatable results compared to the ones who are hand operated or hand cranked. So now what is the test procedure? In this, what we do, that we pass the soil, the fine grained clay soil, through sieve number 40, which is 25 micron size sieve. So once we have passed the material through that, before that we oven dry it, we pulverize it, and then pass it through sieve number 40. And once we have the material, then we add moisture into it, some amount of moisture, depending on the type of the soil. You can add up to like somewhere between 20 to 40% of the moisture initially to the test, to see that how much number of blows it is going to take initially to close this groove. So what is the standard? The standard tells you that if you make a soil pad inside like this and make it level, and then cut it with a groove with the standard grooving tool, and if you allow it to fall freely on the base, then the moisture content corresponding to 25 blows, if it takes 25 blows for half-inch closure of this groove, which is equal to 12.7 millimeter as well. So if you are allowing this to fall freely on the base, and you will see the soil will start getting closer to each other, and if this closer reaches half-inch at 25 blows, then the soil will be considered at liquid limit. So now the moisture content at this point will be the liquid limit of the soil, but it is difficult to do this in a first go. Like you will see that sometimes the half-inch closure will be in 30 blows, sometimes it will be in 40 blows, sometimes it will be in 10 blows. So that is why we cannot reach 25 blows directly, so we will have to perform 4 tests over here. Okay, so what we'll do first, we'll cut the groove with the standard grooving tool, then allow it to fall freely from a height of 10 millimeter, okay, with 2 drops per second, and see that if it is closing up to 12.7 mm over here. So if we will record the number of blows for that, let's say it closes to 12.7 mm in 10 blows. So we will record and number of blows over here is equal to 10 for the first test. Okay. So once that is done, then we will take a portion of the soil from the point where we have observed the closing and take a moisture content of this using any of the standard method or own drying method, etc., which is available with you in lab. Then for the next step, you will change the moisture. Like for example, if it is closing the groove for less than 25 blows, so in this case you need to increase the moisture, okay, because the soil is more fluid. If the soil is more fluid or liquid, then in that case its flow will be more, so it will take less blows for this closure. But if the moisture content is less over here, then it will take more blows to basically flow, because the soil will be more solid. So depending on that, you can increase the moisture content or reduce the moisture content. Like for example, if it takes like 40 blows to close half-inch groove over here, it means your moisture content is much more less than the liquid limit. You need more liquid over here so it can flow easily. So in this case, you will have the water bottle ready with you, spray bottle. With that, you will put some more water into the sample, again mix it and place another sample into it. So you will repeat it 3 times in addition to the one which you have done over here for the 10 number of blows between 10 and 40. Okay, so in one test, like your number of blows is 10, another is 15, then another it is 30, and then another test is like 38. So they will be okay. Okay, but if your test, if you perform the test and it is taken like 70 blows, so you will have to discard that test. Or in particular test, if it like takes 2 or 3 blows and it closes the groove to half-inch, you will also discard that test. Okay, so you will have at least 4 test results with the number of blows between 10 and 40 in their moisture contents as well. So once you have that, you will plot them on a graph. On a horizontal scale, we use the number of blows over here, and on vertical scale we place their moisture content. So for each, like in first test, let's say there were like 15 blows. Okay, in 15 blows we have half-inch closure of the groove, so we've taken moisture content for that as well, and that is, let's say, like 47 over here. Then for the second test, they were like 23 blows and the moisture content was obviously reduced in this case, so let's say 44 for the third test, and then for the fourth test as well. Okay, so now you have graph, which in this you can draw a straight line, average straight line through this, which you can see over here. You will have to manually do this. Maybe the Excel will not draw a proper line for you, so it's better that you draw an average line manually through this. Now once you have drawn this line, you can see over here liquid limit is moisture content corresponding to 25 blows taken for half-inch closure. So you can see over here for 25 blows from this line, you can just determine how much moisture content will be there. Like in this case, it is 42. So 42% is your liquid limit. It means that if your moisture content of this particular soil is greater than 42, then it will behave like liquid. But if it is less than 42, then it will behave like a plastic soil. So hope it's clear, it's easy to understand. Now the use is, of course, that it tells us that a particular soil, when it is going to turn into liquid, when it turns into liquid state, a particular soil, it loses shear strength. It means that if you are building some building on it, if you are using for construction, if you are putting foundation on that, if the soil is in liquid state, it will have zero shear strength. So it means that it cannot sustain the load of your building. And sometimes you have seen while you are driving through this mud puddle, if there is somewhere there is a mud in the clay soil when there is a lot of moisture, and if you are driving through that, your tires just immerse into it and you are stuck in the mud. Why? Because the underneath soil has got zero shear strength. It is in liquid state because it has got too much moisture in it. So from this we can determine that what is the limit at which a particular soil is turned into a liquid. Another advantage is that, let's say you have two soils, soil 2 and soil 1. For both, you plot this graph over here and you see that this is the liquid limit or the flow graph or the flow curve for soil 1, and this is flow curve from 4 point for soil 2. So you can see if we draw a line from 25 blows, this is the liquid limit for soil 1 and this is the liquid limit for soil 2. It means that the soil 2 will turn into a liquid at a lower moisture content. If you have relatively less water compared to the 1, it will turn into liquid. It means that the soil number 1 is a stronger soil compared to soil number 2 over here. So we can prefer this soil for the construction over here in this purpose if we have to choose between two soils. Okay, so this basically not only gives you a comparison between selection of site or selection of material for particular purpose, but also tells you what will be the behavior of the particular soil under the given moisture content in the field. Okay, so you can have field moisture content of particular soil, then you can compare it with liquid, plastic and shrinkage limit of that soil and see that in which state the soil is there in the field. So that is the use of the liquid limit. Now coming to the cone penetration method, okay, that is for the Casa Grande method. The cone penetration method is basically not ASTM standard method, but it is given in British standard BS 1377. So in this we have a cone which penetrates in soil mixture with water. So obviously if the soil is in liquid state, it will offer less resistance to penetration. So the cone can easily penetrate into it. Okay? And if the soil is in semi-solid or solid state, the cone will not be easily able to penetrate. So from this we can determine if the soil is in liquid state or in solid or plastic state. So in this you have got the BS standard equipment, which is over here. The weight of the cone is 80 gram or 0.78 newtons if you are taking in newtons or grams. The cone length, which is this one, is equal to 35 millimeter, and the apex angle is 30 degrees in this case, and the penetration time is 5 seconds. Okay, you will allow it to penetrate up to 5 seconds, while the dimension of the container in which you are going to put the soil is 40 mm by 55 mm. So these all things will be standards, and you will put moisture in the water, and once again, just like previously we did, we will keep on changing the moisture and determine the penetration over here. So liquid limit for a particular soil for the cone penetration test is defined as a moisture content or water content at which the cone will penetrate up to 20 mm in 5 seconds. Okay, so we will allow this, we will put this cone over here and we will allow this to drop inside under its own weight, and if it drops 20 mm or penetrates 20 mm in 5 seconds, then that will be the liquid limit. The moisture content for this soil will be equal to the liquid limit of the soil. So what you will do, you will just prepare the sample using the same technique what we did previously, that you will pass through sieve number 40, which is 425 micron size CV. The sample has to be pulverized and oven dried before you are passing it through CV. So once the material is passed through CV, so the material which is passed through CV, we will take it and we will add water into it. Okay, so then when we put water into it, we will try to bring it in a consistency between liquid and plastic conditions. Okay, depending on your experience, you can put between 20 to, once again, 40 to 50% more water into it for the first try. So once you have done that, the sample is thoroughly mixed and placed in the container. So once we have done that, then we bring the cone down and place it at the top of the soil, like in this state. Alright, and then we press this button and release this cone to drop into the soil under its own weight, to penetrate into the soil under its own weight. So we take initial reading before we allow it to penetrate, and the final reading at the end of the 5 seconds. Okay, so when 5 seconds have passed, then we take the final reading. So the difference of initial and final reading will be the cone penetration. So we need over here the penetration values between 10 and 40 mm over here. So for different samples we will see that if the penetration for the first sample, like if I get penetration is equal to 12, then for the next I can get penetration 18. For the next sample I will increase the moisture content further and I may get penetration up to 30, and then in next I may get penetration up to 35. So for each test we will take a soil sample as well over here at the point where we have done the penetration, and take moisture content as well. So for each penetration value we will have the penetration and we will have the moisture content as well, and once again we will plot them against each other, penetration in millimeter and the moisture content on the vertical or y-axis. So over here you can see the different, we have repeated the test once again for 4 different moisture contents by changing the moisture content of the soil. And remember we said that the penetration corresponding to 20 millimeter penetration is basically the liquid limit. So in this case this is the liquid limit for this particular soil, which is 30 and 40, so this is round about, I would say that 38. Okay, so 38% is your liquid limit for this particular soil using the cone penetrometer method. So you can use the cone penetrometer method as well, but once again cone penetrometer method is standard method in British standard. Usually commonly we follow ASTM standard. So ASTM standard method is the Casa Grande apparatus or Casa Grande test, which we did discuss previously. So similarly you can use over here this test as well and plot the graphs of various soils over here and see that what is the behavior of particular soil compared to in comparison over here to 20 millimeter penetration of the cone. And you can see over here soil number 2 is giving up very easily, and 20 mm penetration is occurring even at a lower moisture content. So if you put little or less moisture compared to the soil number 1 in this soil, it will start flowing, it will lose its shear strength. So this soil is poor soil, so you do not require, if you have like a construction in which you have got to select between these 2 soils, so you will probably select the soil number 1, which is not turning into liquid quickly. It is a stronger soil, its consistency is not easily, or it is not affected by the water at a lower moisture content. So you can have those comparisons as well. In next class we will discuss the plastic limit and the plasticity index. So hopefully it was fruitful lecture today. Let me know if you have any questions in the discussion forum on the SUIT portal. Thank you very much for listening. Good luck.